Hi, I'm Rohan and this is my submission for the K2Think Hackathon. Let's be honest, context switching kills engineering flow. You see a bug, you hunt for the logs, and you lose the thread. I built ArchLens to change that. Think circle to search, but for your entire dev stack. Control Shift A. The screen freezes, you lasso the problem, and you just talk to your desktop. Take this cloud mirror. It's a wall of numbers. Everything is flat except for this one spike in March, the NAT gateway. I'll circle it and ask, why is this ruining my budget? ArchLens doesn't give you a generic FAQ. It points at the egress, it sees the private subnets, and points at the VPC endpoints you forgot to configure. That's not just data, that's an architect in your ear. Why is my bill so high for the month of Feb and March?
The cost increase is almost entirely driven by the NAT gateway, which jumped from $118.90 in February to $4,847.22 in March, a 3,978% rise. NAT gateways are billed hourly and per GB of data transferred, so a large outbound traffic volume, e.g., many private subnet instances uploading data or using the internet, can quickly dominate the bill. Other service only grew a few percent, so they're not the primary cause. The NAT gateway costs skyrocketed due to massive outbound traffic, move S3 and other AWS service traffic to VPC endpoints, consolidate or replace NAT gateways with NAT instances, and restrict internet access to only the resources that truly need it/answer.
Okay, so starting off with the last part of the demo where I will go through the architecture. The voice came out a bit choppy because the speech model is doing it on a streaming basis. And as you can see, we have an electron-based front end, which starts off with the region and optional voice. Once we go over to the backend, we have an IPC favored Python-based backend, where each of the line is being streamed from the K2Think API. So what we're trying to do is first we capture the primary monitor, and based on the user selection, we give that screen capture and the voice capture to the K2Think API. The K2Think model is not multimodal, so we need to convert the audio into text to speech. For that, I'm using Whisper. And for vision, we can use a vision-based model like Google Flash, but I'm using the OCR model. So it's a very basic OCR model that can just read the screen. And all of this information gives K2Think the abilities to be able to become multimodal. It can read what's on the screen, it can listen, and it can speak back in audio. So once we start receiving back the information from the K2Think API, we have to do some post-processing to remove the think tags. And based on the selection on the backend, we can either use a model called Kokoro for the audio, or we can move towards another model that's called Piper. I'm currently using Kokoro. And the final speech to text is then played out to the user through their speakers or headphones. And all of this happens within a few seconds. It's very fast. And my aim for this project was to use K2Think's thinking ability and this fast response rate for a super fast custom assistant that's always there for you.